All right, you guys, we're going to get started on chapter 5. Get excited. We just finished quadratic equations. Now we're going to take a look at polynomials. So the degree of our function, meaning that power associated with things, is going to get bigger. All right. As we ease into chapter 5, today is actually a pretty straightforward lesson. However, there are a number of rules and properties you'll want to understand. A lot of these you've already seen before, okay? Whether it was in Algebra 1, geometry, or maybe even earlier this year, but some of these properties you've already seen. So I'm just gonna briefly kind of run through things, okay? And kind of mention what they're all about. So a product of powers, when we're multiplying two powers, meaning they have the same base and they have some sort of exponent tied to them, we add the numbers together. So if I had 2 to the third times 2 to the fourth, that would be 2 to the seventh power, okay? When I'm multiplying powers, I add their exponents. Thus, when I have a quotient of powers, meaning I have something like 2 to the fourth over 2 to the third, I get 2 to the first. I subtract those powers, okay? Negative exponent is likely going to be new for you this year. So negative exponents don't actually make the number negative, they flip, okay? So if your number's on the top of a rational expression, it's going to go to the bottom. If your number's on the bottom, it's going to move to the top, all right? So if we have 2 to the negative third, that's 1 over 2 to the third. Or we could have 1 over 2 to the negative third, which flips that way. So if it was on the top, it moves to the bottom. If it was on the bottom, negative exponent's on the bottom, it moves to the top. All right. Power to power is the next one we're going to take a peek at. And this is very kind of, I think, intuitive as far as things go. So when we have a power to power, we're going to end up multiplying the two together. So if we have 2 to the fourth, and we're going to cube it, this becomes 2 to the 12th power. And if you want to think of it that way, you have 2 to the fourth, 2 to the fourth, 2 to the fourth. 4 plus 4 plus 4 is also 12. So we could break it up and use the power rule as above if we wanted. You get the same result. All right. When we have a power of a product, this is almost like the distributive property kind of, or that same idea where something is outside the parentheses, it gets moved to everything inside. All right. And that's what happens with the power of a product. So if I have like 2x cubed, this becomes 2 cubed x cubed, or 8x cubed. All right. Power of a quotient, same deal as the power of a product, except you have some sort of fraction. So let's say we have 2 over x, and we're cubing it. We're going to get 2 cubed over x cubed, which is 8 over x cubed. All right. The very last thing is the 0 power. All right. And anything to the 0 power is always going to be 1, not 0. Okay. And I kind of want to show you where this idea comes from. It actually comes from our quotient property above. So if I do 2 to the third over 2 to the third, that's 2 to the 3 minus 3, which is 2 to the 0. But keep in mind, when you have something divided by itself, what do you always get? 1. Thus, anything to the 0 power is always going to be 1. And that, I think, is a new one for sure as well. So today, we're going to be looking at a lot of these properties and simplifying expressions with them. So you do need to kind of keep them straight. All right. So here's a few expressions. We're going to simplify. The goal of simplifying is combine all your numbers. Make sure there's no powers of powers. Make sure your bases only appear one time. Make sure your fractions are in simplest form. And as always, there is no negative exponents allowed in your answer. Okay? So when I see these problems, there's usually a lot going on, okay? It's really easy to make a mistake if you try to do 6 things at once, okay? So what I recommend is doing one thing at a time. So when I see problem A, I'm gonna pick out those numbers first because I know that's -12, okay? So I'm doing one thing at a time. Then I'm gonna pick out the x's, okay? I have x to the 4th times x to the -2nd. When I'm multiplying, I'm going to add exponents, all right? So I wind up with x squared. 4 plus a -2 is 2. And then I'm gonna take my y's. Y squared and y to the 3rd is y to the 5th. And that's your final answer. Again, it's super easy to kind of try to do 8 things at one time. Don't. Do one thing at a time. It's going to make your life a whole heck of a lot easier. When we have these really, confusing quotients, sometimes it might be easier for you to rearrange everything, okay? So this is a strategy you can use. Does order of multiplication matter? No. So what I'm going to do is I'm going to rearrange everything as best possible. All right. So we can kind of see how things break down. So on top, we had a 24, a 5, a c to the 6th, a c to the -3rd, a d to the -2nd, and a d. All right. This is going to kind of make things easier to simplify. All right. The 5's cancel, and then 24 over 6 is 4. So I'm going to have a 4 left up top. When I look at my c's, all right, I essentially have c squared down here, and then I have c to the 3rd up top. All right, c cubed over c squared is just c to the 1st. You don't need to write the 1st if you don't want. And then the last one, we have d to the 7th, and then here we have d to the -1st. Whoops. All right, remember, negative exponent goes to the bottom. So I'm going to have d to the 8th on the bottom because I have 7 d's that are already there. All right. And I'm realizing right now that I made a mistake on this last one because that was a -3. No. Let me just rewrite the d's. My apologies there. If you guys were in class, you would have been screaming at me. So I didn't make that mistake, but here we go. That's a -3 power. So now when I combine the d's again, my apologies. On the bottom, I have d, and on the top, I have d to the -1st. All right. So again, as we simplified, we wound up with 4c, and then this d, negative exponent goes to the bottom. We wind up with 4c over d squared. Apologies on that one. I didn't see the negative there. All right, example C. Very similar mentality. We have a quotient to a power, so that -3 power goes to everything. So we're going to have 2 to the -3. We're going to have b to the -3. We're going to have 3 to the -3. We're going to have a to the -3. If you wanted to, you could have just flipped the fraction initially and then raised everything to the positive 3rd power. It's another way to do the problem. I'm just kind of showing you different ways. So at this point, remember, negative exponents flip. So 2 cubed is 8. That's going to go to the bottom. 3 cubed is 27. That's going to go to the top. All right. We know that b cubed is going to go to the bottom. And we know that a cubed is going to go up top. Negative exponents flip. And then the last one, this is going to be the most common mistake today. When you have a power or a product to a power, all right, a lot of people tend to forget this. So we have -3 to the 4th, we have m squared to the 4th, and we have n to the 4th to the 4th. So 3 to the 4th is going to be 81. We have m to the 8th and n to the 16th. All right. So those are some problems where we're just simplifying using our properties of exponents. Again, no negatives. Fractions should be reduced in simplest form, and bases should only appear one time. All right. Continuing on, looking at operations with polynomials. First off, we want to figure out what a polynomial actually is. Well, a polynomial is basically anything that's going to be very similar to, I'm actually just going to write our quadratic form of a polynomial. So if it's in that standard form where we have coefficients, we have, powers, or x to the first, x to the second, x to the third, we may have a constant in our equation, that's a-okay. But if we have radicals, if we're dividing by variables, if we have negative exponents, that is not going to be representative of a polynomial, okay? So kind of taking a peek at this very first one, I see a radical of x, okay? Polynomials do not have square roots of variables. So this is not a polynomial. Polynomial. All right, part B, taking a peek at things. This is a polynomial. It is a polynomial in two variables, actually. If you notice, all of the variables do have whole number powers, which is great. We have no radicals, we have no negative exponents, all right? Which means this is a polynomial. So I would say, yes, this is a polynomial, okay? If you are to ever state the degree of a polynomial, just so you know, it's always going to be the highest power, okay? So an instance of a quadratic equation like we were studying last chapter, the degree of those polynomials are 2, all right? With polynomials, all right, you're always kind of looking for that highest power. If I have a polynomial that has multiple variables, the degree is going to be the sum, or the highest sum of powers. So in this case, I have a sum of 3, and here I have 1. So the highest sum of powers is 3, which means this is a degree 3 polynomial. All right. Continuing on to the last one, you can see we have negative exponents. Remember, negative exponents flip. So this is essentially what the relation is saying is, your equation, and this is not representative of a polynomial. No. All right, very last thing we're going to look at today. All right, simplifying polynomial expressions. Super, super straightforward. So when we look at these two polynomial expressions, we want to combine like terms, all right? So we wind up with 3x to the 4th. We have 2x cubed. Sometimes people like to cross things off as they use them. That is okay. 2x minus 4x is negative 2x. And then negative 7 plus 5 is negative 2. All right. So as we add and subtract, we are looking to simplify and combine like terms. Typically, you guys, we are going to list in standard form from highest power down to lowest. Subtraction is going to be the same way, but we want to make sure we distribute that subtraction throughout. All right. So we have our two polynomials. 7x cubed minus 4x cubed is going to be 3x cubed. Notice I did nothing to the exponent, okay? In this case, it's like you're saying you have 7 apples and we're subtracting 4 apples. The apples does not change. What changes is that coefficient. So 7 minus 4 is 3. When we're multiplying, then we can do things with the exponents, okay? But not with addition and subtraction. From here, 5x squared minus a negative 3x squared is going to be plus. So we have plus 8x squared, and then we have a positive 4x to finish things off. All right. As we finish here, Multiplying, very similar, all right? Now we're going to add our exponents. So we're multiplying, so we add our exponents. So we wind up with negative 2x cubed plus, whoops, that's not plus, that should be a minus, minus 6x squared, and then negative times a negative is a positive 14x, okay? So just like before, we're going to distribute that negative 2x through, and then we want to use our understanding of exponents to combine. If I have something like a binomial and a trinomial or two trinomials, you want to make sure you distribute everything throughout. So my first step is going to be to distribute the x to everything, plus 8x. Then you're going to want to distribute the 2 to everything. So I wind up with 4x squared minus 8x plus 16. And after that, you're going to want to combine any like terms. It looks like those are going to cancel, and we're left with 2x squared plus 16. And as I'm doing that, that should be a cubed. 2x cubed plus 16. All right. Homework's on the bottom. It's also listed on the weekly planning guide. Please keep in mind as we move forward throughout the year, EOE, when it's listed on your homework assignment, means every other even, or you should be doing multiples of 4. Okay. So 16, 20, 24, 28, 32, etc. Okay. We're going to use that acronym to shorten things up a little bit for you on some of these assignments. So please just keep in mind, EOE means every other even. If you have any questions on the assignment, please ask during our Google Meet live sessions, or you can post something to the discussion board. Hopefully we get chapter 5 started off well. And yeah, if you have any questions, let me know. Otherwise, enjoy your day and good luck on the homework.